At first glance, the deep universe ought to be the easiest part of reality to imagine. Farther away should mean earlier, and earlier should mean simpler, quieter, less crowded, less developed, like walking backward through construction until the noise fades and only bare ground remains. But the deeper we look, the less that comforting picture survives. The oldest visible reaches of the cosmos are not opening into clean emptiness. They are beginning to look busy, structured, chemically worked over, and in places almost unreasonably alive. And once that starts to sink in, the strange thing is no longer just what is happening out there. It is what happens to our sense of reality when distance stops meaning distance and starts meaning time. If you like videos that don't just explain a subject, but slowly change the way it feels, stay with me. This one gets stranger the farther in we go. Most of us inherit a very calm idea of the night sky. It hangs above us as a dark surface with a scattering of points on it, even when we know those points are stars, and those stars belong to a galaxy, and that galaxy is one among many. Some part of the mind still treats the sky like a ceiling. A high ceiling, yes, a beautiful one, but still a kind of backdrop. Space feels open, cold, and mostly empty. The deeper regions of it feel emptier still. That intuition is not foolish. It comes from honest experience. When we stand outside at night, we do not feel surrounded by crowds. We feel the opposite. We feel isolation. The stars look separated by absurd distances. The black between them dominates everything. The darkness seems to be the main event, and the light looks like interruption. Then we build better instruments, stare into a tiny patch of that darkness for an absurdly long time, and the emptiness begins to fail. A deep field image is one of the gentlest shocks in science, not because it screams at us, but because it doesn't. It shows a patch of sky so small you could cover it with something the size of a grain held at arm's length. And inside that tiny patch, the black begins to fill with galaxies. Not a few, not a decorative sprinkle, thousands. Each one carrying stars, gas, history, collisions, death, growth, and the invisible gravity that arranged them. A hole we assumed opened into nothing starts behaving like a pinhole in a blackout curtain overlooking an entire city at night. And even that is only the beginning of the correction, because those galaxies are not all sitting on the same layer like lights on a wall. They are stacked through time. This is the first hard turn the mind has to make. In ordinary life, far away means far away. A mountain on the horizon is distant in the same moment that we are present. A plane crossing the sky is there now, just somewhere else. But the universe does not offer us that kind of simple separation. Light takes time to travel. So when we look outward, we are also looking backward. The deeper the region, the older the scene. We say that all the time, and it can still slide off the brain without landing. Looking into deep space is not like looking across a room. It is closer to opening layer after layer of buried ground at an archaeological site, except every layer is still actively arriving. Nearby stars are relatively recent messages. Distant galaxies are older messages. The most remote visible objects are not merely remote objects. They are early chapters of the cosmos, reaching us late. That means the deep universe is not the edge of a finished thing. It is a delayed archive. And once we understand that, the title stops sounding like hype and starts sounding more literal than it first appeared. Something strange is happening in the deepest regions of the universe, because the deepest visible regions are where we begin to catch reality in forms much closer to its beginning. If those early forms look unexpectedly complex, unexpectedly bright, unexpectedly social, unexpectedly processed, then the strangeness is not cosmetic. It reaches into the timing of how the universe grew up. Before we go that far, it helps to get one stubborn misconception out of the way. People hear that the universe is about 13.8 billion years old, and they understandably picture a sphere with a radius of 13.8 billion light years, as though age and size should match. But the observable universe is much larger than that. The reason is that space itself has been expanding while the light was on its way. So the deepest light we can detect has not been traveling through a static container. It has been crossing a reality that was stretching under it the whole time. This is where common sense begins to slip. We are used to motion happening in space. Cars move through streets. Planes move through air. We are less comfortable with the stage itself changing size while the actors are mid-journey. But that is much closer to what the cosmos does. If you draw two dots on a flexible sheet and then pull the sheet outward, the dots separate, even if neither one is crawling across the surface. Now imagine old light leaving one dot and heading toward the other, while the sheet continues to stretch. The journey becomes stranger than a straight line through emptiness. The signal is not merely crossing distance, it is crossing a changing distance. So when astronomers speak about the observable universe being roughly 93 billion light-years across, they are not saying light broke some ordinary speed limit in an ordinary room. They are describing a history in which the room itself refused to hold still. That alone should be enough to make the deepest universe feel less familiar. But there is another layer. We do not have access to the whole story. We have access to the portion of the story from which light has had time to reach us. That is a very different thing. It means the universe we can observe is not the universe in total. It is the universe available to us from here, from now, within the constraints of light travel and cosmic expansion. Our vision is bounded not only by technology, but by the structure of reality itself. A human life does not prepare us for this kind of limit. We are built for neighborhoods, weather, roads, voices in the next room. Even our largest intuitions are terrestrial. A long wait means days. A long trip means hours. Ancient means older than memory, maybe older than civilization if we really stretch. But out in the deep sky, we are reading signals that began their journey before the Earth existed in its present form. Before the sun had completed even a fraction of the cycles it would one day complete. Before anything like us was available to wonder where the light would eventually land. And still it arrives. That is what makes the next part so unsettling. When the deepest layers of visible time start coming into focus, they do not look like a universe patiently waiting to become interesting. In some cases, they look as though they got to work very early, building faster than expected, shining harder than expected, and leaving behind signs that even before we arrived with our best machines, history had already been happening there for a very long time. To really feel why that matters, we have to go a little closer to the beginning, without pretending we can go all the way. There is a common image of the Big Bang as a bright explosion in a dark place, as though the universe began like a fireball inside pre-existing space. That picture is simple, and almost every part of it misleads. The early universe was not an expanding bomb inside an empty room. It was the expansion of space itself, everywhere. With matter and radiation bound up in conditions so hot and dense that the idea of ordinary objects had not yet arrived. For a long time, light could not travel freely through that plasma. Photons were constantly scattered by charged particles, bouncing and colliding, unable to move in clean straight lines across any meaningful cosmic distance. The universe was brilliant in a sense, but also opaque. Not dark because nothing existed, dark to us because no clear image could pass through it. Then, roughly 380,000 years after the beginning, things cooled enough for electrons and protons to combine into neutral atoms. Suddenly the fog changed. Light was no longer trapped in quite the same way. Radiation could travel, and some of that ancient light is still washing across the sky now as the cosmic microwave background, the oldest direct glow we can observe. Even that sentence can make the background sound more abstract than it is. This is not some optional bonus layer for specialists. The oldest visible light in existence is above us all the time. It fills the sky. It is ancient beyond any human category of ancient. Older than stars like the sun in the forms we now know them. Older than galaxies as finished architecture. A relic from a universe that had not yet formed the luminous complexity we now take for granted. If we had eyes tuned to microwaves, the whole sky would look haunted by infancy. And yet the cosmic microwave background is not the beginning. It is a wall, or maybe better, a curtain. Beyond it lies an earlier universe we cannot directly photograph with light, because light itself had not yet been allowed to travel freely across that environment. So even our deepest direct vision has a built-in stop. The oldest visible surface in the cosmos is already a reminder that there are parts of the story we cannot access the simple way. That matters because after that curtain comes one of the most easily romanticized periods in science, and one of the least intuitively grasped. After the background light was released, the universe entered a long stretch often called the cosmic dark ages. Not dark because nothing was there. Dark because there were not yet stars and galaxies flooding space with visible light. Matter was present. Gravity was working. The future was gathering. But the sky, if anyone had been there to witness it, would not have looked like our sky. It would have been a place waiting for ignition. When the first stars formed, the situation changed again. Their radiation began to alter the hydrogen around them. Later generations of stars and the first active black holes pushed harder, and the universe slowly moved through a process called reionization. Neutral hydrogen across intergalactic space was stripped apart again, and the cosmic medium became more transparent. If the earlier universe had been a fogged landscape before dawn, this was the long, uneven burn-off as the first lights began to take possession of it. That is the broad story. It is beautiful, but still broad. The strange part begins when we ask how fast this happened, how messy it got, and what those first luminous structures actually looked like. Because for a long time, the imagination of cosmic beginnings leaned toward modesty. Early galaxies were expected to be there, yes, but the softer expectation was that they would often be small, primitive, and comparatively restrained. The first chapters of a universe should resemble rough drafts. Then, deeper infrared observations started changing the tone. The James Webb Space Telescope is not magical, but it sits in the one place where a machine can be powerful without being loud. Patient, cold, sensitive, and willing to stare into wavelengths that older instruments could not probe as effectively. This matters because the expansion of the universe stretches ancient light toward the infrared. The deeper back in time we try to look, the more the original light has been pulled out of the visible range we instinctively imagine. So if we want a better look at very early galaxies, we do not just need a sharper eye. We need an eye that can meet old light where expansion has moved it. That is one reason Webb changed the conversation so quickly. It was not merely seeing farther in some generic sense. It was opening a cleaner path to epochs that had been present, but difficult to resolve properly. And once that path opened, astronomers began finding objects from extremely early times that did not sit comfortably inside the calmer versions of expectation. Some galaxies from the first few 100 million years after the Big Bang appeared unexpectedly bright. Some appeared unexpectedly massive. Some seemed surprisingly evolved for their age. Not modern, not finished, not evidence that everything we knew had collapsed, but developed enough to force more serious questions about how quickly the universe was assembling luminous structure. This is where it becomes important not to oversell the tension. Science is full of first impressions that later become more measured after better data, better modeling, or simple patience. The right response is not breathless certainty, it is sharper attention. Even so, sharper attention is exactly what these deep observations deserve, because the recurring pattern is difficult to ignore. Again and again, the early universe has looked less like a bare field and more like a place where construction was already well underway. The emotional force of that is easy to miss if we leave it as a specialist's puzzle. So bring it back to ordinary experience. Suppose you walk into a clearing where you were told a town will one day be built. You expect dirt, scattered materials, maybe a few early foundations. Instead, you find lit windows, intersecting roads, smoke from chimneys, and metal in the ground that suggests fires have already burned there for years. That would not mean the town is ancient in the normal sense. It would mean your timeline for how quickly it could become itself needs work. That is closer to the feeling of some of these observations. The surprise is not just that there is something there. It is that the tempo of becoming seems, in places, alarmingly efficient. And the strangeness sharpens further when we stop looking only at brightness and mass and start looking at chemistry. Heavy elements do not appear for free. The very early universe was mostly hydrogen and helium, with a few tiny traces of lithium. The richer chemical palette of later cosmic history had to be forged inside stars and then spread through supernova explosions and other violent processes. Carbon, oxygen, iron, silicon, the ingredients of planets, rocks, blood, electronics, and dust clouds all belong to a universe that has already lived through stellar generations. So when early galaxies begin to show signs of chemical enrichment, they are telling us that time inside them has not been empty. Even if the cosmos as a whole is still young, history has already been happening locally. Stars formed, burned, died, and left debris behind. The supposedly fresh ground already contains ash. That is not a decorative detail. It is one of the clearest ways the deepest observable universe starts feeling less innocent than we expected. Ash is a quiet kind of evidence. It does not shout the way a blast does. It sits there and changes the meaning of the scene. A forest with ash in the soil is no longer a first forest. A room with smoke in the curtains is no longer an untouched room. In the same way, an early galaxy with heavy elements in its light is not just a newborn object blinking into existence for the first time. It is a place where prior cycles have already unfolded. Stars have lived enough life to alter the chemistry around them. They have made and scattered the ingredients that only arrive after time, pressure, collapse, and death. That matters because chemistry is one of the universe's least sentimental clocks. We can debate appearances. We can wonder whether brightness was overestimated, whether dust changed the interpretation, whether lensing helped one object look more extreme than it is. But when we begin to detect the fingerprints of elements that require stellar processing, the story gains a different weight. The young universe stops feeling merely young. It starts feeling young in age and already burdened with history. This is one of the reasons the deepest regions now feel strange, in a way that reaches beyond spectacle. The old intuition said distance would give us simplicity. Instead, distance is giving us evidence of rapid inheritance. A galaxy only a few 100 million years after the beginning can already carry signs that other stars came before it, burned hot, died hard, and changed what came next. The early universe begins to resemble a place where one event does not wait politely for another. It cascades. Sometimes the language around this gets flattened into a single word like mature, which can be useful and also slightly misleading. These galaxies are not mature in the sense that they have settled into the calm, layered forms of many later systems. Some are compact, turbulent, intensely star-forming, and physically small by the standards of large present-day galaxies. But mature, in this context, means something narrower and still startling, more luminous, more assembled, more chemically evolved, or more structurally ambitious than older models had prepared us to expect so soon. And that small phrase, so soon, is carrying almost all the weight. Cosmic time sounds spacious until we divide it properly. A few 100 million years can feel enormous from the perspective of a human life, because everything about us is short. Civilizations rise and fall inside slivers of that span. Entire biological lineages can transform inside fractions of it, but compared with 13.8 billion years of cosmic history, a few 100 million years is still the opening movement. It is not the age of the universe settling into itself. It is the universe barely beginning to lift its head. So when deep observations suggest that the opening movement already includes unexpectedly bright galaxies, rapid star formation, and early chemical processing, the unease is not theatrical. It is structural. It suggests that the young cosmos may have found efficient routes to complexity faster than many comfortable narratives assumed. Even that sentence can make the process sound too deliberate, as though the universe had a plan. It did not. There was no intention in it, no decision, no preference for speed. There was gravity, density differences, cooling processes, radiation, collapse, merger, turbulence, and chance. But from where we stand, intention is not required for surprise. A river does not plan to carve a canyon, and the canyon can still exceed expectation. The deep universe is beginning to look like that. Not purposeful, just more forceful in its unfolding than our older mental picture allowed. This is also where the sky stops behaving like a collection of isolated objects and starts behaving like a society. When people first get interested in cosmic distance, they often imagine individual galaxies hanging alone in darkness, each one remote and self-contained, like ships too far apart to matter much to each other. There is some truth in that image at the largest emotional scale. Space is lonely. The distances are real. But galaxies are not just decorative islands. They form inside a larger gravitational landscape. They gather in groups, feed along filaments, merge, distort each other, cluster, and participate in structures far bigger than their visible edges suggest. And one of the newer deep field shocks is that this social life appears early too. In some of the deepest surveys, astronomers are not merely picking out lone, ancient galaxies. They are finding evidence of groups and proto-clusters, larger associations that hint at shared environments and emerging structure surprisingly far back in time. Again, this does not mean the early universe looked exactly like the local universe. It did not. But it does mean that the cosmic web, the large-scale arrangement of matter into filaments and nodes, was already guiding the gathering of galaxies in ways that become visible earlier than many people instinctively expect. That changes the emotional picture. The deepest observable universe is not only a place where lights turn on one by one in empty dark. In places, it is more like coming over a ridge expecting wilderness and finding crossroads. Not a finished metropolis, not a fully paved world, but intersections, companionship, traffic of a kind. Early hints that gravity was not merely building objects, it was building neighborhoods. This is easy to underrate because large cosmic structure is hard to feel. A group of galaxies does not register in the body the way a crowded street does. The scales are too large, the times too long, the motion too slow. Human perception is biased toward events that happen fast enough to threaten or reward us. We are exquisitely tuned for the movement of animals, the moods of faces, the fall of rain, the suddenness of impact. We are almost useless by default at feeling 100 million years of gradual assembly. So we compensate with thought. We make analogies, and not because analogies are decorative, but because without them, the truth never becomes real. A proto-cluster in the deep universe is not literally a village crossroads, but that image helps because it restores the missing intuition. A crossroads tells us something simple. Movement is being organized here. Paths that could have remained scattered are beginning to meet. Density is becoming destiny. Once that happens, the future changes. More traffic arrives because traffic is already arriving. More matter gathers because matter is already gathering. Structure amplifies itself. Now, widen the frame again. What is organizing those crossroads? What decides where the traffic can accumulate in the first place? This is where the visible universe becomes a little deceptive. Because if we judged only by what glows, we would miss most of what is doing the shaping. The stars and gas we admire are not the whole architecture. They are the lit surfaces. Under them lies dark matter, which remains one of the strangest ordinary facts in modern science. Ordinary, not because it is conceptually easy, but because astronomy leans on it constantly. Galaxies rotate the way they do. Clusters hold together the way they do. Large-scale structure forms the way it does. Again and again, the visible mass alone does not seem to be enough. Something unseen is contributing the gravitational framework. Dark matter has never been photographed the way a moon or a nebula can be photographed. It does not emit light for us to admire. It reveals itself by influence, by the way things move, bend, gather, and remain bound. In that sense, it behaves less like an object we stare at and more like a hidden support system we infer, because the visible structure would otherwise sag or fly apart. If visible matter is the timber, brick, glass, and smoke of a cosmic city, dark matter is the unseen scaffolding that told those materials where falling was easier and where accumulation could hold. It is one of the deepest reasons the universe looks organized at all. And once we understand that, the deepest regions begin to look strange in a new way. Not merely because they are full earlier than expected, but because the thing making early fullness possible is mostly invisible. That should sound familiar in a broader human sense. We are always tempted by surfaces. We judge a city by its skyline and forget the pipes, cables, legal codes, debt networks, and buried foundations without which the skyline never rises. We judge a life by what can be seen in public and miss the hidden structures that shaped every visible choice. The universe seems to work with the same indifference to our preferences. The bright part is real. It is also incomplete. And the deeper we look, the less the lit surfaces can explain themselves. Once that idea settles in, the phrase deepest regions stops sounding like a place and starts sounding like a condition of seeing. We are not traveling to a special province of the cosmos where the rules become exotic. We are watching the earliest visible layers of the same universe we inhabit. And those layers are exposing something easy to miss in ordinary life. The visible part of any system is often the least sufficient part. That is especially true in cosmic dawn, when the first generations of stars and galaxies were not just decorating empty space, they were changing the medium through which later light would move. This is what makes reionization more than a technical milestone. Early luminous objects did not simply appear inside a neutral universe and leave it untouched. They began transforming intergalactic hydrogen itself, carving expanding bubbles of ionized space into what had been a more opaque cosmic fog. If that sounds remote, picture dawn in a valley where the mist has not lifted yet. At first, only the highest ridges catch light. Then, bright edges begin to burn through the fog, pockets clear, distances become readable in fragments. Separate illuminated zones widen until the misted spaces between them shrink and vanish. Reionization is not that seen, literally, but it helps recover the logic. The first fires did not merely add brightness, they altered the transparency of the world. That means the earliest galaxies were participating in a kind of environmental change on the largest scale imaginable. Their radiation helped make the universe more traversable to later light. They were not simply first residents. They were part of the process that made the cosmic landscape itself easier to see. So when we look into the deepest observable time and catch their signatures, we are not only seeing ancient objects, we are seeing agents in a transformation that changed what the universe was like to observe. And this is where the emotional texture shifts again, because now the strangeness is no longer just that early galaxies existed, or even that some looked more developed than expected. It is that their emergence begins to feel less like isolated ignition points and more like a coordinated atmospheric event across cosmic history. Not coordinated by mind, but by physics playing out across an expanding universe, with countless local collapses adding up to a global change in visibility. That pattern keeps repeating. The deeper we look, the less the old image of lonely objects in passive darkness can hold. The early universe starts behaving like a system whose parts were already interacting with their surroundings in profound ways. And as soon as we say that, another pressure point appears. What about black holes? Black holes are already strange enough in the present-day universe. Regions where gravity has won so completely that beyond a boundary called the event horizon, escape is no longer possible. Objects that can shape stars, bend light, regulate the centers of galaxies, and sit at the hearts of systems much larger than themselves. But in the deep universe, they acquire a different kind of tension, because some black holes seem to have grown very large, very early. This is not a minor bookkeeping issue. A supermassive black hole is not a decorative object you can slip casually into the timeline. If you find one weighing millions or billions of suns in a universe that is still very young, you have to ask how it got there so quickly. Did it begin from unusually large seeds? Did gas fall into it at extraordinary rates? Did mergers accelerate its growth? Are we misreading some cases? Are there formation pathways we have not fully appreciated yet? These are technical questions on paper, but their emotional logic is simple. It is the same feeling you would have if you arrived at a shoreline shortly after the tide was meant to begin rising and found cliffs already carved, channels already deep, and boulders already moved. Something about the pace of change would need rethinking. That does not mean there is a cosmic crisis every time a large, early black hole appears in the literature. Astronomy is not a courtroom where one surprising object overturns the case. But taken together with the brightness of some early galaxies, the signs of rapid enrichment, and the appearance of structured environments, early black holes contribute to a broader impression. The first billion years may have contained more aggressive growth, more efficient assembly, and more nonlinear acceleration than the softer versions of the story implied. It is tempting at this point to turn the whole thing into a slogan. The early universe grew up fast. That is not entirely wrong. It is just too smooth. Growth in the real cosmos is rarely uniform. Some regions run ahead, some remain dim, some gather matter along favorable filaments, some collide, some are dust-shrouded. Some are transformed by feedback, where intense radiation and outflows from stars or active black holes begin to regulate further growth. The deep universe is not strange because it did one simple thing too quickly. It is strange because even near the beginning, it already seems capable of producing a wider range of outcomes than our instincts like. And instincts are the real, quiet antagonist in this story. We are built to think beginnings should be plain. A child's drawing starts with one line, then another. A building starts with excavation, then frame, then walls. A city starts sparse and takes generations to thicken. Those patterns are sensible in the scales where we live. They become unreliable when applied to a universe governed by gravity across vast expanses of matter, with tiny early density differences that had eons, by human standards, to amplify. What feels quick to us can still be enough time for cosmic structure to run surprisingly far. The body does not know what to do with 300 million years. It rounds it down into very early and leaves it there. But 300 million years is also 300 million years. Plenty of time for stars to be born, blaze through short violent lives, explode, enrich gas, trigger more formation, and set off chains of consequence. Plenty of time, under the right conditions, for gravity to deepen wells, feed central objects, and encourage gathering in favored regions. The deep universe feels strange partly because we use the word early as if it means empty, when in fact it only means early relative to the whole. That difference matters. It keeps us from misunderstanding what the observations are actually pressuring. The surprise is not that physics worked. The surprise is how energetically physics appears to have worked in some places, and how quickly traces of accumulated history become visible once Webb and other instruments sharpen the view. Still, there is a trap here. Once a subject becomes culturally associated with surprise, everything starts getting narrated as disruption. Every early bright galaxy becomes a revolution. Every unusual spectrum becomes an overthrow. Every ambiguous signal becomes the crack that breaks the old universe open. That is bad thinking, and science at its best resists it. The more honest picture is sturdier and, in a way, more interesting. Precision cosmology has not failed. The broad framework of an expanding universe with dark matter, ordinary matter, radiation, and dark energy remains extraordinarily successful across many scales and observations. The microwave background still speaks coherently to later structure. Large-scale patterns still make sense in ways that would be impossible if the entire framework were adrift. The strange thing happening in the deepest regions is not that the cosmos has stopped obeying intelligible rules. It is that the rules are generating outcomes whose tempo and texture we are still learning to predict properly. That distinction preserves the dignity of the mystery. We do not need a collapse of all understanding to feel the pressure of a changing picture. Often, the more unsettling moment is not when a model dies, but when it survives while forcing us to notice how much nuance we had left out. The universe may be less wrong than we are simplistic. And there is one more reason to stay careful. The deep universe is difficult to observe in ways that are easy to forget once the images become famous. We do not hover above it with unrestricted access. We observe through wavelength limits, sensitivity thresholds, foreground contamination, dust, selection effects, redshift interpretation, incomplete samples, and the awkward fact that extraordinary objects are sometimes the easiest to notice first. In other words, the deepest universe may be strange, but our window into it is strange too. We are peering through conditions, not through purity. Which makes the next question unavoidable. If the view is partial by nature, how much of the strangeness belongs to the cosmos, and how much belongs to the shape of the keyhole we are looking through? That question is not a retreat from the mystery, it is part of the mystery. A deep image of the universe feels authoritative because it is beautiful, and because beauty often tricks us into thinking we are seeing more completely than we are. But a deep field is not a godlike view. It is a narrow cone of ancient light selected by physics, by instrument design, by the wavelengths we can capture, by how long we stare, by what dust blocks or reddens, by what brightness thresholds we can cross, and by simple cosmic luck. The early universe we see is real. It is not the whole early universe. It is the part that has managed to announce itself across an expanding, aging cosmos and arrive in a form our instruments can interpret. That should not make the view feel weaker. It should make it feel more intimate. We are not receiving a final map. We are receiving messages that survived. There is something almost maritime about that. Imagine standing on a shore after a storm, trying to reconstruct what happened far out at sea from what drifts in. A plank with a strange cut on it means one thing. A burned rope means another. A child's shoe, another. You are not making things up. You are reading real evidence. But the evidence comes filtered by survival, by direction, by timing, by what sank, by what floated, by what the currents chose to carry. Deep cosmology works with far greater rigor than that image, of course, but the emotional logic is similar. Observation is never divorced from the route by which the observation became possible. This is why astronomers are careful about redshift, which is one of those words people hear often without fully absorbing its physical tenderness. Ancient light has not merely traveled a long way. It has been stretched while it traveled. The expansion of the universe lengthens its wavelength, sliding it toward the red and then into the infrared. In a static universe, distance might leave the message intact, apart from dimming. In our universe, the message reaches us changed by the journey. It arrives older, not only in origin, but in texture. That is part of what makes the deep cosmos so unlike ordinary distance. If a friend shouts from the far end of a long hall, The voice weakens, but the room does not stretch the words lower and slower while the sound moves. The universe does something closer to that with light. The ancient signal falls toward longer wavelengths, while the space between source and observer expands. So we do not simply need large telescopes. We need instruments suited to translated light. And translated light can mislead before it clarifies. A candidate galaxy may first appear impossibly early, then later spectroscopy refines the estimate. A bright source may look like one thing in imaging and later reveal another structure. Dust may veil a system or alter how its light is interpreted. Gravitational lensing can magnify distant objects by bending light around foreground mass, turning the universe itself into an accidental optical device. This can help us, but it also complicates the reading. The deep cosmos is not only distant, it is optically treacherous in elegant ways. That is why the most useful attitude here is not either certainty or cynicism. It is patience under pressure. Something genuinely strange is showing up. The right task is to learn its shape without rushing it into a slogan. This becomes clearer when we remember that even the apparently simplest cosmic relic, the microwave background, is not perfectly smooth. At first pass, it is astonishingly uniform, one of the great visual lessons in humility. The early visible universe looks almost featureless compared with the lumpy, violent richness of later time. But look more closely and tiny fluctuations appear, minute differences in density and temperature. Wrinkles so small they would be easy to dismiss if the later universe did not depend on them so completely. Those tiny departures from sameness became everything that followed. Galaxies, clusters, filaments, planets, oceans, blood, cameras, languages. All of it grew from a universe that looked nearly smooth, but was not perfectly so. That alone is worth pausing over. The deep universe is not merely a remote place full of odd objects. It is the scene in which microscopic imbalances became destiny. The visible grandeur of the present cosmos is the amplified afterlife of almost invisible early differences. And even there, in that oldest light, some unsettled oddities remain. Certain large-scale patterns in the microwave background have been debated for years. Asymmetries, alignments, the cold spot. Anomalies that may turn out to be statistical quirks, foreground complications, or hints of something subtler in the early cosmos. The important thing is not to turn them into forbidden knowledge. They are not that, nor should they be dismissed as meaningless simply because they are inconvenient. They belong to the honest edge of the story, features interesting enough to study, uncertain enough to treat carefully, and revealing enough to remind us that the most ancient visible layer still has not given up everything cleanly. There is a mature kind of wonder in that, not the wonder of fireworks, but the wonder of knowing the data are real and the interpretation is still alive. A universe that keeps part of itself provisional is not withholding. It is just larger than our appetite for closure. The same is true when we talk about the first stars. For many people, the phrase "first stars" sounds satisfyingly singular, as though there must have been a moment when darkness cleanly ended and a first generation lit the stage. Reality was almost certainly rougher. The first luminous objects emerged in regions where gas had fallen into dark matter halos and cooled enough to collapse. Some may have been extraordinarily massive compared with many later stars, living short and furious lives. Some may have exploded with such violence that they rapidly enriched surrounding gas. Others may have contributed to the growth of black hole seeds. But the details remain an active area of research, partly because seeing those first generations directly is so difficult. Here again, the deep universe resists a tidy painting. We are not looking back at a ceremonial opening. We are trying to reconstruct a staggered, uneven ignition from scattered but improving evidence, some valleys lit before others. Some stars may have been monsters by stellar standards, burning hard and dying young. Some galaxies may have assembled around these violent beginnings, faster than our comfortable narratives had imagined. The first light of the cosmos may have come less like a sunrise, and more like many separate fires, catching in a landscape too large to witness at once. That image matters because it returns us to the human problem inside the science. We are always tempted to compress sprawling realities into scenes simple enough for the mind to hold. One dawn, one beginning, one first galaxy, one answer to the question of why the deep universe looks strange. But the farther observation reaches, the less reality behaves like a single, clean scene. It behaves like a history too large to take in at once, where different regions develop at different tempos, and our line of sight catches only the portions allowed by physics. So yes, our window distorts. But that distortion is not a flaw in the story. It is part of the truth being told. We live at a specific time, in a specific galaxy, with specific instruments, trying to infer the earliest visible ages of an expanding universe from delayed, stretched, filtered light. That is not a neutral God's eye position. It is a local act of reconstruction. And the more honestly we accept that, the more astonishing the success becomes. Because even from this limited shore, we have managed to infer that the apparently empty darkness is thick with time, that the oldest visible light still carries wrinkles from cosmic infancy, that the first galaxies may have assembled with startling speed, and that some of the earliest places we can observe already bear the chemical signatures of previous stellar death. At some point, the deep universe stops feeling empty and starts feeling crowded with inheritance. Which raises a harder possibility. What if the deepest strangeness is not only that the young universe forms structure quickly, but that our entire category of emptiness has been wrong from the start? That possibility sounds philosophical until physics begins backing into it from multiple directions. Emptiness, in everyday language, means not much is there. A vacant room, an open field, a stretch of road with no cars on it. Cosmic emptiness feels like the same thing at larger scale. The black between galaxies looks like absence. The intervals between stars look like vacancy. Even when we know the distances are full of fields, particles, radiation, and geometry, the eye keeps reporting a simpler verdict, mostly nothing. But the universe has been quietly correcting that verdict for a long time. Even intergalactic space is not a pure void. It contains thin gas, background radiation, gravitational influence, magnetic structure, relic particles, and the expanding geometry of space-time itself. Within galaxies, the apparent gaps are shaped by matter we cannot see directly, and by force fields we notice only when they act. Even the oldest visible light does not pass through a truly empty stage. It crosses a medium and a geometry that alter what can be seen and how. So when we speak about the deepest regions of the universe, we should be careful with the word regions. It tempts us into imagining remote rooms at the far side of a giant house. What we are actually dealing with is more like depth within a layered process. The farthest visible galaxies are not sitting on a clean outer border. They belong to earlier slices of cosmic history along our line of sight. The darkness between them is not sheer nothingness. It is a low-density, evolving environment through which light, matter, and gravity have been in conversation for billions of years. Once that clicks, the old emotional contrast between object and emptiness starts to soften. A bright galaxy is not a jewel pinned onto a dead black cloth. It is a local expression of a much larger arrangement that includes invisible scaffolding, surrounding gas, radiation backgrounds, merger histories, and the global expansion of the universe. The dark is not a blank. It is the condition within which structure grows. That becomes even more obvious when we think about the cosmic web. On the largest scales we can model and map, matter is not distributed evenly like flour sifted across a table. It forms filaments, sheets, nodes, and voids. Galaxies trace this underlying architecture imperfectly but meaningfully, gathering where matter has pooled more effectively, leaving wider, sparse volumes between. The universe on the largest scales is not chaos. It is a pattern of preference. Preference created by gravity, not design, but preference all the same. If we could see the large-scale web directly with ordinary eyes, the emotional experience of the night sky might be completely different. Darkness would not feel like mere separation. It would feel like distance inside a structure, like standing in a valley at night and seeing only scattered windows, not because the land between houses is empty, but because roads, terrain, weather, and topography remain hidden in the dark. Our ordinary vision makes the cosmos look sparse, partly because it does not show us the supports. There is a quiet humiliation in that. Human intuition tends to trust the visible seen far too much. We do this with societies, with ecosystems, with economies, with history. We do it with our own lives. We assume what stands out is what matters most, and what does not glow cannot be doing much. The deep universe keeps defeating that habit. The brighter the object, the more likely it is sitting inside a larger, invisible arrangement that gave it a place to become bright at all. And nowhere is that more unnerving than in the problem of dark matter itself. Not because dark matter is spooky in the casual sense, but because it is so normal inside modern cosmology and still so unresolved at the level of identity. We infer it from rotation curves, from gravitational lensing, from cluster dynamics, from structure formation, from multiple independent lines of evidence. We have compelling reasons to treat it as real in some form, yet we still do not know, in the straightforward way people crave, what it is made of. That means one of the basic ingredients of cosmic architecture remains physically anonymous. Imagine trying to understand cities while knowing that most of their structural load is being carried by a material nobody has ever held in the hand. Imagine being able to measure its effects on bridges, walls, and foundations with great confidence while still being unable to point to it on a table and say, "There it is." That would be a strange civilization to belong to. This is a strange universe to study. Its visible forms keep making sense in ways that depend on an unseen component, whose nature remains open. And that unseen component matters intensely in the deep universe, because early structure does not grow in a vacuum of explanation. Small density variations in the young cosmos had to be amplified. Dark matter halos provided deepening wells where ordinary gas could collect, cool, and eventually light up. Without some hidden gravitational framework, the luminous universe would struggle to assemble the way it does. The early galaxies now drawing so much attention may owe their timing and location to something we still cannot directly identify. The deep sky, then, is not only strange because it contains unexpectedly early brightness. It is strange because that brightness may be the visible symptom of an invisible substance already shaping events with quiet authority. There is a second layer to this, and it touches the meaning of evidence itself. Light is how we first fell in love with the cosmos. It is also how the cosmos teaches us restraint. The things we most easily admire are stars, nebulae, galaxies, glowing gas, hot dust, supernova remnants, accretion disks. But if the universe's architecture depends heavily on what does not shine, then our emotional loyalty to brightness becomes a kind of bias. We keep wanting the story to belong to the luminous parts, because those are the parts that feel available to imagination. Reality does not owe us that convenience. The same lesson applies to cosmic voids, which sound like absences and are better understood as part of the pattern. A void in the large-scale universe is not simply a useless empty hole. It is a consequence of where matter did not accumulate as effectively, a counterpart to the dense filaments and nodes where galaxies cluster. The emptier places help define the fuller places. The pattern includes both. Like negative space in a drawing, the thin regions are not outside the structure. They are one of the ways the structure becomes legible. By now, the phrase, "something strange is happening," should be starting to shift tone again. It is no longer only about a handful of record-breaking distant galaxies. It is about a recurring correction. Whenever we try to reduce the deep universe to a simple stage set, the correction arrives. Distance turns into time. Time turns into layered evidence. Emptiness turns into medium. Isolated objects turn into networks. Brightness turns into aftermath. The visible turns out to depend on the invisible. And the farther back we look, the more decisively these reversals pile up. That piling up creates its own kind of unease, because if the deep universe keeps defeating our simplest categories, we have to ask whether that is a temporary problem of incomplete science or something more durable about the relationship between human minds and cosmic reality. The honest answer may be both. Science improves the map, instruments sharpen, models get revised, data accumulate. Some tensions weaken, others strengthen. But there may be no final stage at which the universe becomes intuitively native to us. It may remain intelligible without ever becoming natural to a nervous system built for survival on a small planet. We may keep learning, keep refining, keep making the deep sky more exact, and still find that exactness is not the same thing as psychological comfort. That is not a failure of knowledge. It is one of its mature consequences. And once we allow that possibility, another strange layer appears. The early universe may not only be telling us how quickly things formed, it may be revealing that the gap between what is real and what feels easy to imagine is itself one of the central facts of existence. That gap is easy to ignore when reality behaves politely. Everyday life lets us move through a world that mostly agrees with our scale. Doors fit bodies, Streets fit walking speed. Weather unfolds on timescales our skin can register. If something is approaching, we can usually tell. If something is large, it generally looks large. The senses are not perfect, but they are close enough to keep us alive. Cosmology is where that truce breaks. In the deep universe, things can be older than intuition can hold, farther than any ordinary notion of distance can survive, and more causally connected than the eye would ever guess from the black between them. Signals arrive long after their source is changed. Structures depend on invisible mass. The earliest visible chapters already contain evidence of prior death, and the farther we push observation, the more obvious it becomes that our inherited mental furniture was not built for this house. There is something almost tender in that mismatch. We tend to talk about the human mind as though its greatest weakness is ignorance, as though the main problem is simply not having enough information. But information is only part of it. The deeper challenge is scale friction. Our thinking drags against certain realities because those realities are too large, too delayed, too distributed, or too indirect to become instinctive. Even after we understand the equations qualitatively, even after we can repeat the facts, some inner layer keeps trying to reduce the universe to scenes small enough to feel ordinary. That is why the phrase, edge of the universe, causes so much trouble. It sounds concrete. We picture a boundary, a shell, a frontier line one could approach in principle if only the ship were fast enough. But the observable edge is not a wall waiting to be reached. It is more like the boundary of what can have become visible to us by now. Move elsewhere in the cosmos, and the observable sphere would recenter around that new location. The edge is not a brick perimeter. It is a limit born of time, expansion, and light travel. And that means the deepest visible regions are not special because they occupy some privileged outer zone. They are special because they mark how far back our present circumstances allow us to see. This matters more than it first appears. If we treat the deep universe like a place, we make it too static. If we treat it as a visibility condition, everything sharpens. The strangeness is not parked at a distant coordinate waiting for our attention. It is generated by the relationship between the cosmos and the observer. Ancient light, expanding space, finite age, instrument sensitivity, and local viewpoint all cooperate to produce the scene we call deep time. The mystery lives partly in the universe and partly in the geometry of access. That does not make the cosmos observer, created in any soft, philosophical sense. Reality is not depending on us to exist. The galaxies were there whether or not anyone would one day detect them. The first stars ignited without an audience. Black holes began feeding without a witness. But what counts as the deepest visible universe is always a statement from somewhere, from some time. It is local to the observer, even when the subject is cosmically remote. There is a profound loneliness in that, and also a kind of grace. Every civilization, if others exist, would inherit its own horizon. Every observer would live inside a different archive, depending on where and when they arose. Some might see a younger sky than ours. Some, in the far future, may see less. Because expansion is not only stretching light from the past, it is also carrying parts of the universe away, so effectively that light emitted from them in the future may never arrive here at all. That is one of the strangest facts in all of cosmology, and it still does not get the emotional attention it deserves. The observable universe is not just a static inventory, it is a changing relation. There are regions whose ancient light can reach us now because it's set out under earlier conditions, while future light from those same broad realms may be permanently lost to us as expansion accelerates. In that sense, visibility itself has a history. The sky is not only a record of what has been, it is also shaped by what can still remain in causal contact. Bring that back down to the body for a moment. A human life feels like a span in which the world remains recognizably available. Places may be far, but not cosmologically unavailable. Messages may be delayed, but not for billions of years. We do not naturally inhabit a universe where access can close not because of censorship or distance in the ordinary sense, but because the geometry of space-time itself has made further exchange impossible. Yet that is part of the world we actually live in. This is one reason dark energy became such an emotionally important discovery, even before most people knew its name. In technical terms, it refers to the observed accelerated expansion of the universe. In human terms, it means the large-scale cosmos is not merely opening, It is opening in a way that changes the fate of what can ever be shared between regions. The great pattern of galaxies is not fixed on a single, timeless stage. The stage keeps changing the terms of visibility. There are new hints, still not settled, that dark energy may not behave exactly like the simplest constant picture we often teach. That matters scientifically, but even without leaning on frontier uncertainty, the established part is enough to alter perception. The universe is not just strange in its youth, it is dynamically strange in its long future. Some of the deep light we receive is precious partly because it comes from a cosmos that will not always remain equally open to observation. In other words, the deepest regions are not simply far, they are part of a vanishing conversation. That line may sound overly poetic until you notice how literal it is. Every photon we catch from the early universe is a successful crossing. It left a source under one set of cosmic conditions and arrived under another. It survived expansion, dilution, interference, and time. It entered an instrument built by creatures that did not exist when it began. It became data, then inference, then shared understanding. The chain is astonishing, not because it flatters us, but because it reveals how much of reality had to line up for any of this to be knowable at all. And yet, even this success carries a caution. The more we learn about ancient light, the more we realize how selective survival can be. Bright objects announce themselves. Dust-obscured systems may hide. Unusual classes of source may be easier to notice than ordinary faint populations. Early sensational cases attract scrutiny first. This can skew the emotional picture if we are not disciplined. The deep universe might look exaggeratedly dramatic in early headlines, not because the drama is fake, but because the first things to cross our interpretive threshold are often the loudest. Still, once corrections are made, once samples improve, once interpretation matures, the broader pattern remains difficult to domesticate. The young cosmos was not a blank prologue. It was already running. Galaxies were gathering. Stars were living and dying. Chemistry was deepening. Black holes were beginning their long influence. The medium itself was being transformed by radiation. Hidden structure was guiding visible structure. And all of this was happening in a universe whose oldest direct light still carries unresolved features, and whose future visibility may shrink under continued acceleration. That is more than a list of curiosities. It is a pressure on how we imagine reality. The deep universe is not strange because it contains a few exceptions. It is strange because the farther back we see, the less our comfortable categories, empty, simple, isolated, fully visible, intuitively scalable, continue to apply. At some point, that forces a reversal in the whole emotional direction of the story. We began with the idea that deeper meant more primitive, and therefore easier to understand. We are arriving instead at a harder truth. Deeper often means closer to the conditions where the universe becomes less familiar, more layered, and more revealing of the limits built into our point of view. And once that reversal is in place, one final question begins to press from underneath it. If even the ancient light that does reach us is only a fraction of what the universe has been, what should we make of the enormous remainder we will never see at all? The honest answer is that we should make very little of it with confidence, and very much of it with humility. There is a temptation, whenever the observable universe begins to feel too limited, to rush beyond it in imagination, and treat the unseen remainder as a stage for whatever idea we already wanted to believe. Infinite replicas, hidden symmetries, bubble universes, endless repetitions, strange topologies. Some of these possibilities emerge from serious theoretical work. Some belong more to the looseness of popular speculation. But the key point is simpler. The universe beyond our observable horizon may be vast beyond our direct access, and yet the fact that it lies beyond our access is not permission to fill it casually. The unseen deserves the same intellectual discipline as the seen. That discipline does not reduce wonder, it sharpens it. Because even if we say almost nothing concrete about what lies beyond the observable horizon, what we already know inside the horizon is enough to alter any thoughtful person's sense of reality. We live inside a finite sphere of visibility centered on our own position, watching light that began under ancient conditions and crossed an expanding cosmos to find us. We know there is more beyond that sphere, simply because the observable limit is a limit of access, not necessarily a limit of existence. And we know that some of what is beyond us now may never communicate with us in the future. That combination, more exists, but not all of it can ever become part of our experience, is one of the least instinctive truths in science. Human beings are not comfortable with inaccessible reality. We prefer ignorance to be temporary. We like to believe that if something matters enough, then better machines, more time, and more effort will eventually bring it within reach. Often that confidence is healthy. It has served science well. But cosmology contains a harder lesson. Some horizons are not technical. They are structural. There may be pages in the book that are not merely unread yet, but unreadable from where we stand. That is not a romantic statement. It is a physical one. And that physical limit throws a different light on the deepest regions we can observe. Ancient galaxies, the microwave background, the first stages of reionization, the rapid enrichment of young systems, the early growth of black holes. All of it becomes more precious once we realize that the observable archive is not a complete library. It is a surviving selection, a bounded inheritance. We are not strolling through all of cosmic history at leisure. We are listening to the part of the symphony whose notes could still make the crossing. This is why the deep universe can feel emotionally different from other scientific frontiers. In many fields, discovery expands territory while leaving the basic intuition of availability intact. There may be more to learn, but the world still feels open in principle. Deep cosmology does not always grant that comfort. It expands knowledge while reminding us that knowledge comes from a local shore, under local conditions, inside a finite window of access. The result is not despair. It is a more exact kind of reverence. That reverence becomes even more grounded when we stop picturing cosmic history as a neat staircase and start seeing it as a branching, uneven accumulation. One of the subtler mistakes we make when telling the story of the universe is to imagine that the past is simpler because it is earlier, and the future is more complex because it comes later. But complexity is not a single tide rising uniformly across all things. The young universe had simple ingredients in one sense, and already differentiated outcomes in another. Some regions gathered matter faster. Some stars may have been giants that lived fast and ended violently. Some black holes may have found early feeding routes. Some galaxies may have remained faint, while others pushed far ahead. Some signatures survive, others vanish. So the deep universe is not a clean museum of beginnings. It is a rough, partial sample of beginnings unfolding unevenly. That is one reason the record matters so much. We are not merely looking for the oldest object as a trophy, though the culture around astronomy can sometimes make it seem that way. The deeper goal is to understand tempo. How quickly did matter assemble into stars? How quickly were those stars able to alter their environments? How rapidly did heavy elements begin circulating? How soon did galaxies start behaving like members of larger environments, rather than solitary experiments? How early did black holes become consequential? How soon did the universe begin building the long causal chains that one day led, much later, to planets and observers? Tempo is the hidden heartbeat of this story. And the heartbeat keeps sounding a little faster than the older, softer imagination expected. Again, caution matters. Faster than some expectations is not the same thing as impossible. Tension is not collapse. Revised modeling is not embarrassment. Science is healthiest when it can absorb pressure without pretending pressure is nothing. But from the standpoint of human perception, the distinction between impossible and unexpectedly early is not the main emotional event. The main event is that the universe keeps proving more active, more layered, and more willing to produce significant structure under early conditions than our casual mental sketches allowed. This is where the phrase hidden reality becomes almost unavoidable, not in the sense of secret knowledge, but in the more sober sense that much of what is most real in the universe is not obvious at first glance. The night sky hides time. Darkness hides structure. Brightness hides dependence on invisible scaffolding. Ancient light hides the fact that it has been translated by expansion. Smooth backgrounds hide the tiny fluctuations that later became everything. The visible universe hides the greater reality beyond observation. Even the word young hides the amount of local history a few 100 million years can contain. The deep cosmos keeps showing us that concealment is normal. That realization travels well beyond astronomy. The visible layer of any system tends to flatter us with immediacy. We assume the obvious cause is the real cause, because it arrived first in awareness. But systems become systems precisely because what matters is distributed across levels. Foundations disappear under buildings. Institutions disappear under events. Historical pressures disappear under decisions. The deep universe is not simply teaching astrophysics. It is tutoring perception. It is teaching us to distrust any first picture that looks too complete. And maybe that is why cosmic observation can feel unexpectedly intimate. At first, it seems like the least personal subject imaginable. Distant light, primordial fluctuations, invisible matter, expansion histories. Nothing about that sounds like the scale of a human life. Yet the lesson it carries is strangely close to ordinary existence. We live among surfaces that are never the full story. We mistake what is present to the eye for what is most causally powerful. We forget how much of any moment is inherited from long chains we did not witness. We underestimate hidden structure until its consequences become impossible to ignore. The universe is not mirroring us, of course. It is not sending a message, but the patterns rhyme. And when patterns rhyme across scales, meaning can emerge without anyone preaching it. By now, the title has widened almost beyond itself. Something strange is happening in the deepest regions of the universe. Yes, the earliest visible cosmos appears more crowded, chemically busier, and in some cases, more developmentally ambitious than many people once assumed. Yes, hidden structure seems to be doing more of the work than visible matter admits on its own. Yes, observation itself is bounded, translated, and selective in ways that make the visible archive both extraordinary and incomplete. But underneath all of that is an even deeper strangeness. The universe does not merely contain things we do not know. It contains conditions under which knowing is always partial, always local, always dependent on survival of signals across time and change. We do not stand outside reality and inspect it whole. We stand inside it, late, small, temporary, catching ancient light as it arrives. And still, somehow, enough arrives to let us begin reconstructing the opening chapters. That should not make us feel triumphant. It should make us careful and very quiet, because the farther we go into the deep universe, the more it begins to feel less like a remote spectacle and more like a fact about our own condition. We are creatures of a late and local moment, trying to understand a reality that was already old before our star was born, and that will remain larger than our access, no matter how sharp our instruments become. Which means the deepest regions are not only telling us about the early cosmos, they are telling us what it means to be an observer at all. To be an observer in this universe is to arrive after the opening has already begun and before the whole performance can ever be heard. That is not melancholy by default. It is simply the geometry of our position. We came into being very late compared with the first light, very early compared with whatever future the cosmos still contains, and very locally compared with the full spread of what exists. The astonishing part is not that our knowledge is incomplete. In a universe like this, incompleteness is the expected condition. The astonishing part is that incompleteness still permits depth. We can know that the oldest direct light comes from a universe only a few 100,000 years old. We can know that tiny fluctuations inside that young plasma became the seeds of later structure. We can know that dark matter shaped the landscape within which ordinary matter gathered. We can know that the first stars and galaxies changed the transparency of the cosmos. We can know that some early galaxies were already bright and chemically processed enough to complicate older expectations. We can know that black holes became influential early enough to strain easier stories. We can know that the visible universe has a horizon, and that the horizon is not the end of existence, but the limit of present access. That is a remarkable list for any species, let alone one that evolved to notice shadows in grass and fruit in trees. And yet the value of that list is not only in what it tells us about the universe, it is in the kind of knowledge it is. Deep cosmology does not hand us control. It does not even hand us completion. It hands us orientation. It teaches us where we are in relation to a past we never witnessed and a larger reality we will never fully possess. That is a different kind of gift than certainty. In some ways it is better, because certainty closes too easily. Orientation stays alive. When we ask why the deepest regions of the universe now feel strange, one answer is that the data are genuinely provocative. Another is that our tools have improved enough to reveal tensions that softer instruments could not force us to face. But a third answer is more personal. The strangeness grows because we are losing the illusion that the cosmos should be intuitively arranged for our kind of mind. The deep universe is where that illusion thins out. Near home, we can still pretend reality is made of objects and distances. A planet, a star, a galaxy, empty space in between. That picture works well enough for conversation, well enough for childhood, well enough even for many practical calculations. But farther back in time, farther out in observation, it starts to fray. Objects become events inside evolving media. Distances become histories of transmission. Emptiness becomes low-density process. Isolation becomes connection through hidden structure. The more primitive our language feels, the more layered the universe turns out to be. That can sound abstract, so it is worth returning again to the plainest available image. The night sky seen with naked eyes. It looks sparse. It looks settled. It looks almost silent. Our ancestors saw it that way, and in one sense, so do we. But now, the apparent silence has an entirely different texture. We know that every dark patch is not equally empty, that tiny black windows can be packed with galaxies across staggering depths, that some of the faintest sources belong to epochs when the universe was still near the beginning, and that the most ancient direct light of all still arrives from every direction, like a cooled afterglow of a once opaque reality. The same sky remains overhead. It is we who have become less innocent about what it is. That is one of the quietest powers of astronomy. It rarely changes the physical object of attention. It changes the felt meaning of what was already there. A person can look up before learning cosmology and after learning cosmology and see the same moon, the same stars, the same black. Yet the second person is standing inside a denser world. The darkness carries delay. The faint points carry age. The emptiness carries structure. The silence carries traffic too slow and large for the senses. The ordinary scene survives, but the ordinary reading does not. Maybe that is why the deep universe matters so much culturally, even to people who never study it formally. It offers one of the clearest available experiences of reality, becoming less naive, without becoming less beautiful. In many parts of life, learning more can flatten wonder. Mechanism replaces mystery, and the emotional charge leaks away. Cosmology often does the opposite. Mechanism deepens the mystery, because the mechanism itself turns out to be grander, less intuitive, and more existentially charged than the easy first picture. Learning that light has a speed is interesting. Learning that looking outward means looking backward changes the sky. Learning that the universe is old is interesting. Learning that some of the earliest visible galaxies were already chemically marked by earlier stellar death changes what young can mean. Learning that galaxies exist is interesting. Learning that they gather along invisible scaffolding, influence their surroundings, and emerge inside a cosmic web changes what a bright point of light is allowed to be. Learning that the cosmos expands is interesting. Learning that expansion creates horizons of visibility and may eventually sever entire broad regions from future observation changes what access means. These are not just additions to knowledge. They are revisions of intuition. And intuition is stubborn. It keeps trying to drag us back towards scenes small enough to feel manageable. That is why every generation needs fresh language for the cosmos. Not because the facts vanish, but because the mind keeps reducing them. We keep turning the universe back into a ceiling, back into dots on black, back into a distant spectacle, instead of a dynamic history in which we are late participants. Good narration, good science communication, good thought itself has to resist that reduction again and again. Not by exaggerating. Exaggeration actually helps the reduction, because it turns the cosmos into theater. Then the viewer gets to enjoy astonishment without undergoing correction. The deeper task is calmer. It is to say exactly what the universe is doing, exactly what the evidence suggests, exactly what remains open, and let reality carry the pressure. Reality is strong enough. That is especially important when discussing frontier observations. The oldest candidate galaxies, the earliest signs of heavy elements, the puzzles of black hole growth, the ambiguities in background anomalies, the hints around dark energy, none of these need inflated language. They only need to be placed in the right frame. Not as proof that everything we know is broken, not as decorative curiosities, but as pressure points in a picture that remains coherent while becoming more exacting. There is a grown-up kind of awe in that. A universe that completely collapses under scrutiny can become cartoonish. A universe that survives scrutiny while revealing more hidden depth than we expected becomes harder to dismiss. It stops being a collection of marvels and becomes a sustained confrontation with layered reality. Which brings us back to tempo, because tempo is still the pulse under all of this. The deep universe feels strange, partly because it violates the emotional schedule our minds would have preferred. We would have liked a more leisurely beginning, a long, simple age, sparse early structures, clear stages, neatly separated. Instead, the first billion years already contain intensity. Stars ignite, matter gathers, chemistry deepens, black holes feed, radiation transforms the medium. Structure appears in groups and webs. There is no laziness in the opening. Even cosmic infancy contains acceleration, feedback, inheritance, and consequence. And once we see that, it becomes harder to tell a false story about our own place. We are not living in the calm center of a straightforward world. We are living in a late chapter of an extraordinarily active history, whose earlier pages were already full of events before our planet existed. Human life can feel central because it fills the only scale we naturally inhabit. But cosmology keeps relocating us, not to diminish us, but to situate us more truthfully. We are downstream from fluctuations in an early plasma, downstream from the birth and death of stars that made heavy elements, downstream from galaxies gathering in dark matter wells, downstream from black holes shaping environments, downstream from reionization clearing the cosmic fog, downstream from an expanding space-time that carried old light for billions of years until it found instruments made by a species of temporary observers. There is something clarifying in that word, downstream. It makes history feel physical. We are not detached minds floating above the universe describing it from nowhere. We are consequences inside it, trying to infer the upstream conditions from the materials and signals that made it this far. And what has made it this far is already enough to tell us that the deepest regions are not simple at all. They are full of pressure, inheritance, and unfinished interpretation. They are where the universe begins to show us not only what happened long ago, but how misleading it is to expect reality to come arranged in scales that fit the hand. If we keep following that thought, there is only one direction left for it to go. Not toward despair, and not toward easy comfort, but toward a recognition that might be the strangest part of all. The more partial our access becomes, the more extraordinary it is that access exists at all. That may be the point where the whole subject turns from scale into intimacy. It is easy to think that learning how limited our access is should make the universe feel colder. We cannot see beyond certain horizons. We cannot photograph the first instant. We cannot directly watch most of cosmic history unfold the way we watch weather or fire. Even the deepest images are delayed, filtered, and incomplete. On paper, that sounds like a recipe for distance, but in practice, it can produce the opposite effect. The more precisely we understand the conditions under which knowledge becomes possible, the more miraculous the fact of any knowledge begins to feel. Not miraculous in the supernatural sense, miraculous in the plain sense of improbable alignment. Ancient photons had to survive. Space had to expand in a way that preserved a readable archive rather than erasing all coherence. Matter had to form stars. Some stars had to live and die fast enough to enrich later gas. Galaxies had to assemble and scatter light outward. A small planet around an ordinary star had to produce chemistry capable of awareness. That awareness had to become curiosity. Build instruments, develop mathematics, argue with itself, correct itself, cool mirrors in space, and wait patiently for faint infrared signals from an early universe that never knew it was being watched. When you lay the chain out like that, the familiar phrase "we are looking back in time" stops sounding like an educational slogan and starts sounding like a material achievement of the cosmos itself. The universe made conditions in which pieces of its own beginning could eventually be reconstructed by one of its late byproducts. That does not make humanity the point of the universe. There is no evidence for that and no need for it, but it does make consciousness feel less trivial than some modern habits of thought allow. Not more important than stars or galaxies, just more surprising. A universe this large, this old, this structurally hidden, this indifferent to intuition, has still produced local witnesses capable of learning what ancient light means. That fact sits quietly inside all deep cosmology, whether we mention it or not. And perhaps that is why the deepest universe never remains purely technical for long. However careful we are with redshifts, selection effects, halo models, radiative transfer, and all the other necessary machinery, the emotional consequence keeps returning. We are present at the receiving end of events that began before any familiar frame of human meaning existed. The data are cold. The situation is not. Take something as simple as a spectrum from a very distant galaxy. To a specialist, it is lines, intensities, wavelength shifts, signal to noise, interpretation. To the rest of us, it is easy to miss what kind of object a spectrum really is. It is a trace left by ancient matter after a journey through expansion and time. It is not an image in the ordinary sense. It is closer to a voice print carried across almost unimaginable history. The shape of that trace lets us infer composition, motion, distance, age. From a few delicate signatures, whole worlds of interpretation open. We learn not by touching the ancient galaxy, not by visiting it, not by seeing it in any direct human manner, but by noticing how its light has been marked. That way of knowing should make us humble. It is delicate. It is inferential. It depends on models, calibration, cross-checking, community critique. But it should also make us less dismissive of inference itself. People often reserve emotional respect for what can be grasped directly, as though indirect knowledge were second-rate. Cosmology shows the opposite. Some of the deepest truths available to us are available only indirectly. Their power does not come from closeness. It comes from coherence. And coherence is one of the most underrated forms of beauty in science. A universe becomes more believable, and in some ways more astonishing, when pieces across enormous difference begin to fit together. The microwave background tells one part of the story. Large-scale structure tells another. Galaxy surveys add another. Early galaxies add pressure. Chemical enrichment adds memory. Black hole timing adds tension. Dark matter explains patterns at one level while remaining unresolved at another. Dark energy shapes the long future, even as its character remains debated. The picture does not become less strange as the pieces connect. It becomes more compelling because the strangeness is no longer random. It has structure. This is why the deepest observations matter, even when they complicate earlier expectations. A tension between data and model is not a scandal. It is a place where reality is asking for finer thought. Sometimes the tension dissolves with better measurements. Sometimes it leads to revised astrophysical assumptions without needing a revolution in the whole cosmological framework. Sometimes it hints at something more profound. We do not know in advance which case we are in. But that uncertainty is part of how real knowledge grows. It grows where the fit is good enough to trust and incomplete enough to demand more. The deep universe is now full of exactly that kind of demand. Not because everything is broken, because enough is working that the mismatches mean something. Think again about those early galaxies that seem brighter, heavier, or more chemically evolved than many people once imagined. Their importance is not only in the specifics of each object, it is in the pressure they place on our emotional timing. They keep saying, in effect, that the early cosmos may have had more momentum than our comfortable storytelling allowed. That is not a detail to file away. It changes the feel of cosmic dawn. The beginning starts to resemble not a quiet waiting room, but a place where gravity, gas, radiation, and feedback rapidly found ways to matter. Even the phrase cosmic dawn can mislead if we are not careful. It sounds smooth, almost pastoral, a gentle brightening after darkness. But actual dawn on Earth is a local and continuous experience. Cosmic dawn was dispersed, uneven, and violent in many places. First light did not roll evenly across a single horizon. It emerged in different regions at different times, under different conditions, from stars that may have been far more massive and short-lived than many familiar stars today. What followed was not serenity, it was transformation. The medium changed. The future transparency of the universe changed. The possibilities for later structure changed. So when we say something strange is happening in the deepest regions, one thing we mean is that the opening chapter of visible complexity may have been harsher, faster, and more structurally consequential than the calm phrasing of textbooks once let us feel. That feeling grows stronger when we remember how much of later existence depends on those early accelerations. Heavy elements did not simply appear for our benefit. They were forged in stars, scattered by death, recycled into new systems. Planetary chemistry, rocky worlds, Atmospheres, oceans, even the mineral and biological conditions of life downstream all depend on a universe that became chemically creative. The early signatures of enrichment in distant galaxies are not remote curiosities. They are some of the earliest readable evidence that the long chain leading to material complexity was already underway. Again, downstream is the right word. We are reading upstream conditions from downstream consequences, and the signal is good enough to tell us that the upstream world was more active than the old blank slate image allowed. There is something oddly calming about accepting that, not because the universe becomes smaller. It becomes larger, not because uncertainty disappears, it remains, but because the false simplicity falls away. Reality stops pretending to be arranged for easy intuition. Once that pretense is gone, the deep cosmos can be met more honestly. Ancient light is partial, horizons are real, hidden structure is normal, early history was not empty. The universe is under no obligation to have been simple just because it was young. That sentence has a wider reach than astronomy. We make the same mistake with nearly everything inherited from the past. We assume earlier means less layered, less burdened, less entangled. Then we look closely and find long preparation, invisible scaffolds, buried consequences, and feedback loops already running before the surface seemed to begin. The universe only happens to display that truth at the largest scale. And perhaps that is why it can feel so strangely consoling, even while it dismantles our intuitions. It does not tell us that reality is chaos. It tells us that reality is richer than first sight, and that hidden order often precedes visible outcome. The deepest regions of the universe are strange, not because they break meaning, but because they force us to expand the size of meaning until it can hold what is actually there. Once we do that, even the old question, what are we looking at, begins to change. We are looking at beginnings, yes, but not untouched beginnings. We are looking at darkness, yes, but not empty darkness. We are looking at distance, yes, but not distance alone. We are looking at a record of structure appearing earlier, faster, and under more hidden guidance than human intuition was prepared to expect. And still there is another layer waiting beneath that. Because all of this, every deep field and every ancient spectrum, and every inferred halo, and every disputed anomaly, has unfolded within a universe that is not only revealing its past to us, it is also carrying its future away. That future matters because it changes the emotional meaning of the present archive. If the universe were expanding at a steady, gentle rate forever, the story would already be strange enough. Ancient light would still arrive delayed. Horizons would still exist in a meaningful sense. We would still be local observers inside a finite sphere of access. But accelerated expansion adds another note to the whole composition. It means the large-scale cosmos is not just unfolding. It is, in a very real way, relaxing parts of itself out of reach. The phrase can sound dramatic if handled badly, so it is worth keeping the mechanics plain. On the largest scales, galaxies are not simply moving through a static emptiness like debris through air. Space itself is expanding, and that expansion is accelerating. Over enough time, distant systems become more isolated from one another in terms of what signals can still be exchanged. The great cosmic web that seems, from our present position, like a connected, large-scale structure, is not guaranteed to remain equally communicative forever. That makes our era unusual, in a way most people never feel. We happen to live at a time when the universe has aged enough to build stars, galaxies, planets, and observers, but not so far that the large-scale evidence of cosmic history has vanished from view. The microwave background is still detectable. Distant galaxies are still visible. The broad structure of the universe can still be inferred across enormous scales. This was not true in the very early cosmos, because not enough history had occurred. It may not be true in the very distant future, because too much visibility will have been lost. So there is a narrowness to our moment that is easy to miss. We tend to think of ourselves as ordinary, because every present moment feels ordinary from the inside. But cosmologically, the present is a strangely privileged observational interval, late enough for complexity, early enough for access. That does not make us chosen. It makes us situated. And once that lands, the deepest regions of the universe acquire another layer of meaning. They are not only evidence about what happened long ago, they are part of a temporary inheritance available to observers like us because of when we happen to exist. There may come a time, unimaginably far ahead, when hypothetical astronomers in some future galaxy would find the cosmos much harder to read. The background glow would be redshifted beyond practical detectability. Distant galaxies would have faded from observational reach. The clues that let us reconstruct cosmic history would be thinner. The universe would not have become less historical. It would have become less legible from within. That possibility makes the present feel less like a default and more like a window. We are so used to thinking of knowledge as something that simply accumulates that we forget it also depends on conditions. Readable archives do not last forever in every form. Civilizations know this on the small scale. Libraries burn, languages vanish, records decay, context is lost. Cosmology shows the same principle on the largest scale. The universe does not merely contain information. It contains eras in which some of that information is easier or harder to recover. The thought is almost archival in character. We are readers in a library whose shelves are slowly moving apart in the dark. And still, enough remains within reach to tell us a staggering amount. We know that the oldest light we can directly observe comes from an epoch when the universe first became transparent. We know that tiny early irregularities grew into later structure. We know that hidden mass shaped visible assembly. We know that the first luminous sources changed the cosmic medium. We know that some surprisingly early galaxies were already bright enough and enriched enough to complicate soft expectations. We know that black holes began mattering early. We know that the observable universe is not the whole universe. We know that some parts of the cosmic conversation are already receding beyond future reply. That last phrase matters, future reply. In human affairs, a reply is delayed because of distance, conflict, silence, or death. In cosmology, reply can fail for a more indifferent reason. The structure of space-time can simply cease to permit it. The source may still exist in some form. Light may still be emitted there, but it will never arrive here. Not because of malice, not because of error, because the evolving geometry of the cosmos has made shared visibility finite. There is something deeply sobering in that. It turns the universe from a passive backdrop into a temporally fragile relation. Not fragile in the sense of weak, fragile in the sense that accessibility has conditions. Even the most durable cosmic structures do not automatically remain mutually knowable forever. This helps explain why deep cosmology can feel almost emotional, even when the subject is handled with strict restraint. We are not just measuring distance, we are encountering the fact that reality exceeds any permanent field of view, and that access itself has a history. Some things become visible only after enough time has passed. Some things stop being visible when too much time has passed. Knowledge lives in that corridor, and that corridor is where we are. The mind resists this because it would prefer a more stable arrangement, a world where all that exists remains in principle available forever, a world where enough patience could defeat every horizon, a world where the unknown is simply the not yet known. But the universe, at least on these scales, does not promise that. It offers something more austere and perhaps more beautiful. It allows partial beings to reconstruct a vast history from incomplete signals during a limited interval of readability. That is a harsher gift than omniscience, and a more meaningful one than spectacle. It also changes the texture of scientific caution. When astronomers argue over the interpretation of a distant source, the redshift of a candidate galaxy, the significance of a background anomaly, or the behavior of dark energy, the argument can look narrow from the outside. But beneath the technical details is something more human. We are trying to read an ancient and incomplete archive, well before parts of it slip further into silence. Precision is a form of respect. Carefulness is not the enemy of wonder. It is one of wonder's mature forms. And nowhere is that more necessary than in the public appetite for disruption. People love headlines that promise a broken universe. A telescope discovers something impossible. Everything we knew was wrong. Physics must be rewritten. Sometimes, reality does deliver revolutions. More often, it delivers tension that has to be lived with for a while. The deepest regions of the universe are full of that kind of tension now. The young cosmos appears, in important ways, more active and already more structured than many casual versions of the story suggested. Yet the broader framework still holds remarkably well. The result is not a shattered picture. It is a picture under pressure. Pressure is where some of the best science happens. It is also where some of the best narration belongs, because pressure preserves the dignity of the unknown without sacrificing the dignity of what is already known. We do not need to choose between certainty and confusion. The real state of affairs is stronger than either. The universe is intelligible enough to reconstruct, strange enough to resist simplification, and large enough that even good reconstruction keeps opening into larger questions. So when we return to the deepest observable regions, we should do it with a cleaner emotional frame. We are not peering into a freak zone where nature forgot its own rules. We are peering into early chapters of a coherent but not fully domesticated cosmos. We are seeing young systems that may have become luminous, enriched, and environmentally consequential with surprising speed. We are seeing hidden architecture underwrite visible structure. We are seeing the archive under conditions of translation, delay, and finite access. And we are doing all of this during an era when the universe still permits the evidence to be gathered. That last part gives the entire exercise an undertone that is hard to name without overdoing it. Gratitude is close, but not quite enough. It is more like a sharpened awareness of contingency. We could have existed in a less readable epoch. We could have lacked the tools. We could have mistaken the sky for decoration and gone no further. Instead, by a chain of causes far older than us, we live at a time when ancient light can still be read. The deep universe is strange, but part of its strangeness is that it can still be known at all. And once that becomes clear, the remaining question is no longer just what the oldest galaxies are doing, or how early structure formed. It is what kind of reality this must be, what kind of world we are actually inside, if even its partial visibility is enough to humble every easy category we brought to it. It must be a reality in which hiddenness is not the exception, but one of the governing conditions of truth. That sounds severe at first, because hiddenness is usually treated as a problem to be eliminated. We want better images, better models, clearer maps, stronger signal, fewer ambiguities, and all of that is good. The progress of science depends on reducing needless obscurity, but the deep universe suggests that there is another kind of hiddenness that does not vanish when knowledge improves. It only changes form. We see farther and discover older layers. We refine the picture and learn that visibility itself has structure. We solve one opacity and arrive at another. Not because the universe is taunting us, but because layered realities do not become flat just because we get smarter. In that sense, the deepest regions are not unique. They are exemplary. They show in an extreme form what is probably true everywhere. Appearance is always a thin slice. A city at night looks like windows and roads, but its real life depends on pipes, codes, power grids, habits, debts, weather, memory, labor, and buried decisions that no skyline can confess on its own. A forest looks like trunks and leaves, but its real structure runs through roots, fungi, water tables, soil chemistry, insects, climate, and deep time. A person looks like a face and a voice, but no face or voice reveals the full architecture of memory, inheritance, fear, desire, language, injury, luck, and private thought beneath it. The cosmos appears to obey the same law at the largest scale. Light is real. It is also the surface. The deeper story depends on what shaped the light, delayed the light, translated the light, and in many cases, remained dark while the light was being made. That is why the early universe can feel more crowded the better we understand it. We are not just finding more objects. We are finding more layers of causation around every object. This helps explain a feature of astronomy that can be hard to communicate well. The excitement in a new observation often does not come from the object itself, but from the number of assumptions it forces into simultaneous view. A distant galaxy is never only a distant galaxy. It is also a statement about star formation, gas cooling, dark matter halos, chemical enrichment, radiation transfer, dust, cosmic expansion, instrumental sensitivity, and the survival of light across time. To see one source clearly is often to feel half a dozen larger systems pressing behind it. That is one reason deep cosmology rewards slow attention better than quick amazement. Quick amazement gives you the object. Slow attention gives you the stack. And the stack is where the real emotional force lives. A very early bright galaxy matters not only because it is remote, but because its brightness implies a chain of prior success. Matter had to gather, gas had to cool, stars had to form. Some of those stars may have lived brief, violent lives. Heavy elements had to begin appearing. Feedback had to shape subsequent growth rather than simply extinguish it. Light had to escape. Expansion had to stretch that light into the range we can now detect. Instruments had to be designed to catch it. Interpretation had to remain careful enough not to mistake artifact for revelation. Every deep object is carrying this kind of burden. The farther back it comes from, the more densely packed the implications become. And still, even that stack is partial. This is what makes the deep universe so difficult to narrate honestly without slipping into one of two failures. One failure is sensationalism, where every new result becomes proof that the cosmos is in chaos. The other is over-smoothing, where every tension is dissolved into reassuring language so quickly that the viewer never feels the genuine pressure. Both are distortions. The truer tone lives between them. The data are often robust enough to challenge older expectations. The broader framework is often robust enough to survive that challenge. The result is a universe that is neither broken nor fully settled. It is intelligible and alive with revision. That phrase, alive with revision, may be one of the healthiest ways to hold the subject. Because revision is not weakness. It is the sign that a picture is absorbing reality. The early universe once lived largely in the domain of theoretical expectation, constrained by indirect evidence and limited instruments. Now ancient light is arriving with greater clarity, and the picture is being pressed by actual objects rather than imagined averages. Some of those objects fit well, some create tension, some may soften under better analysis, some may become more significant with time. This is how a living science behaves when the archive deepens. The feeling of that deepening is unlike almost any other kind of historical revision. In ordinary history, revision means new documents, archaeological discoveries, newly read inscriptions, forgotten voices restored. In cosmology, revision means photons that left their sources before Earth existed, finally arriving in a form we can decode. That fact alone should keep us from speaking too casually about astronomical updates. The archive is not being reopened in the metaphorical sense. It is still physically arriving. There is something extraordinary in that verb, arriving. Ancient light is not just stored somewhere for us to consult. It is in motion. The deep universe is not a shelf. It is a crossing. We know the young cosmos by intercepting emissions, whose journeys took nearly the full age of the universe. Even after all the mathematics and instrumentation, there remains something startlingly simple about that. The past reaches us materially. It does not merely leave traces embedded in local rocks or fossils. It sends its own radiance forward. That is why deep cosmology can produce such a specific emotional after effect. It does not only expand the universe, it destabilizes the present. The now we inhabit begins to feel less self-contained once we realize how much of it consists of arrivals from elsewhere and elsewhen. The sky overhead is not merely contemporary scenery, it is mixed-time reality. Nearby stars belong to one temporal layer, distant galaxies to another, the microwave background to another still. Every look upward is already a composite of eras. No wonder intuition struggles. Intuition expects a single present. But the cosmos we actually observe is a braided present, stitched from signals that left under radically different conditions, and only happen to be co-arriving at our location now. The deepest regions intensify this fact, because their light is among the most delayed, the most stretched, and the most informative about early conditions. They force us to confront the extent to which vision in astronomy is not contact with the present state of remote things, but contact with messages of varied age, assembled into one visible field. Once that becomes emotionally real, the phrase "seeing the universe" changes meaning. We are not looking at reality in a single tense. We are looking at a layered delivery. That layered delivery may be one of the deepest reasons the universe feels stranger the better it is known. The old picture was simpler, partly because it was flatter in time. We saw stars, galaxies, darkness. We now see stages, histories, dependencies, feedback loops, hidden components, and limits of access. The scene did not merely become more detailed, it became more temporally textured. The black sky stopped being a surface and became a record. And records have consequences. They make innocence harder to maintain. Once we know that some very early galaxies already seem to carry signs of rapid growth and chemical history, the word beginning can never return to its old, clean meaning. Once we know that the visible universe depends on a hidden scaffolding we still cannot directly identify, the word matter cannot return to its old, simple meaning. Once we know that the universe's future may close parts of the archive to later observers, the word now cannot return to its old disposable meaning. The deepest regions are not only telling us about the cosmos, they are revising some of the most ordinary words we live by. Beginning, distance, emptiness, matter, visibility, now. None of them remain quite what they were. And if those words are changing, then so is the emotional frame in which we stand beneath the sky. It becomes harder to dismiss our own moment as merely ordinary when ordinary itself turns out to be lit by ancient transmissions, bounded by horizons, and nested inside structures that exceed direct perception at every scale. That does not make daily life less real. It makes it more layered. A person walking home under city lights is still walking home under city lights, but overhead is not a blank dark. It is a slow-moving archive from which the early universe is still speaking in stretched light. It is a visible ceiling made of delayed messages, hidden mass, and inaccessible remainder. It is a reminder that what feels immediate is often standing inside histories too large to feel without help. And that may be the deeper reason this subject keeps holding people. Not because it offers escape from human life, but because it returns human life to a larger setting without reducing it to nothing. The deep universe does not flatter us. It does something rarer. It situates us. Which is why, by the time we reach the end of this journey, the question is no longer whether something strange is happening in the deepest regions of the universe. That much is clear. The deeper question is what those regions are asking us to become in response. What kind of observers we have to be if we want to live honestly inside a reality that keeps revealing more depth than our first pictures can hold. We probably have to become slower than our first instincts. Not slower in the sense of duller, and not slower in the sense of resisting discovery. Slower in the sense that reality this layered cannot be met honestly with reflex alone. The deep universe keeps punishing haste. Hasty imagination turns early tension into cosmic melodrama. Hasty skepticism waves away genuine puzzles because they are inconvenient. Hasty language smooths pressure too quickly and leaves us with a version of the cosmos that is easier to repeat than to believe. What the deepest regions seem to ask from us is a more disciplined form of attention, one that can hold clarity and incompleteness at the same time. That is harder than it sounds. The mind loves completion. It loves a scene with a stable foreground and background, a few named actors, a timeline that advances in neat order, and an ending that makes the beginning feel inevitable. The universe we actually observe does not cooperate. Its earliest visible epochs are patchy, distributed, and full of processes operating at once. Radiation changes environments while matter assembles. Dark matter shapes structure while refusing direct identification. Ancient light arrives altered by expansion. Early stars may already be seeding later chemistry. Black holes may already be starting their long influence. The large-scale medium is being transformed, while local systems are still struggling into form. It is not that the story lacks order. It has order. But it is the order of many layers moving together, not the order of a simple line. That distinction matters well beyond scientific accuracy. It changes the moral texture of looking. A simple line flatters the observer. It lets us feel that the world is arranged in the sequence we would have preferred. A layered process does not flatter us. It asks us to grow up a little. It asks us to stop expecting beginnings to be pure, emptiness to be empty, visibility to be complete, and hiddenness to be a temporary inconvenience. The deep universe is, among other things, a training ground for intellectual adulthood. That sounds grander than I mean it. The point is quiet. Maturity in this context is just the ability to remain faithful to what the evidence is actually saying, even when it refuses to resolve into easy, emotional categories. Some of the earliest galaxies look unexpectedly bright. Good, let that pressure remain pressure. Some early systems seem chemically enriched enough to imply rapid prior star formation and death. Good, let that deepen the timeline without turning it into myth. Some black holes appear uncomfortably early. Good, let that widen the question of growth channels. The background sky contains unresolved large-scale oddities. Good. Let them remain interesting without becoming cult objects. The universe may be expanding under the influence of something whose simplest description could still be incomplete. Good. Let the future stay open where it is genuinely open. This is not a lesser form of wonder. It is one of the strongest available. Because cheap wonder needs the object to be louder than we are. Mature wonder only needs reality to be itself, and reality, especially at these depths, is more than sufficient. Think about what has already happened just in the visible opening chapters of the cosmos. The universe cools enough to release light. Tiny fluctuations persist inside that nearly smooth glow. Gravity works on those irregularities over immense spans. Dark matter deepens the wells. Ordinary matter follows. Gas cools. The first stars ignite. Some may burn quickly and violently enough to enrich surrounding material almost immediately by cosmic standards. Radiation begins altering the intergalactic medium. Galaxies assemble earlier than our softer pictures liked. Some gather in larger environments. Black holes start growing into future authorities. The fog of the early universe thins under collective illumination. All of this unfolds before the universe is old in the way our language usually reserves that word. No responsible narration has to exaggerate that sequence. It is already extraordinary. The only real work is to let it remain specific. Specificity matters because it protects the strangeness from dissolving into atmosphere. The deep universe is not strange in a vague, poetic sense. It is strange in the sense that the oldest layers we can directly study are not passive backgrounds, but active epochs. Strange in the sense that, very early, can already include ash, structure, environmental transformation, and hidden support systems. Strange in the sense that the more exact the measurements become, the less the old emotional picture of simple beginnings can survive intact. Strange in the sense that our best access to cosmic reality is always late, local, and incomplete, yet still astonishingly powerful. Once we say it that way, another change happens. The deep universe stops feeling like an answer bank and starts feeling like a teacher of method. It teaches us to infer from traces without worshiping speculation. It teaches us that visibility and importance are not the same. It teaches us that unseen structure can be more causally decisive than bright surfaces. It teaches us that time can be present without feeling present. It teaches us that uncertainty is not the opposite of knowledge, but one of the forms knowledge takes at the edge of contact. And perhaps most importantly, it teaches us that revision is not embarrassment. Revision is what truth looks like when new light actually arrives. That last phrase deserves to stay with us. New light actually arrives. So much of modern life is built around the instantaneous that we can forget what it means for reality to require transit. We press a screen and expect immediate access. We measure delay in irritation, not in ages. But cosmology forces us back into a universe where messages travel materially, where distance changes what can be received, and where some of the most important information we have comes from signals that began their journey before our species existed. That alone should change how we think about evidence, patience, and arrival. The sky is not a static display. It is a delivery system stretched across time. And if it is a delivery system, then our role is not merely to admire it. Our role is to learn how to read it without arrogance. That may be the hidden ethical invitation in all of this. Not morality in the narrow sense, more like a discipline of scale, a refusal to force the cosmos into human-sized categories, simply because human-sized categories feel warmer, a willingness to let the universe remain larger than our convenience, while still approaching it with care, rigor, and affection. Affection matters too, though people sometimes avoid that word around science, as if it were unserious. But affection, in the best sense, is just a stable form of attention that does not reduce what it studies. It is entirely possible to approach the deep cosmos with mathematical strictness and still feel a kind of tenderness toward the fact that ancient light exists, survives, and can be interpreted at all. Not tenderness toward the universe as though it were benevolent. Tenderness toward the sheer improbability of contact. Because contact is what this is, however delayed and partial. We are in contact with the early universe, not complete possession, not immediate presence, contact. Enough to know that the opening chapters were already busy with forces and feedbacks we are still learning to narrate honestly. Enough to know that the visible order depends on hidden order. Enough to know that our sky contains signals from radically different epochs, braided into a single field. Enough to know that horizons are real and readability is temporary. Enough to know that a local species on one planet can reconstruct part of an ancient cosmic history from translated light. That should leave a mark on how ordinary life feels. It should make easy certainty a little harder to enjoy. It should make visible surfaces seem less self-explanatory. It should make the night less decorative. It should make the word empty feel provisional. It should make the present feel less sealed off from upstream events. It should make our own lives, for all their local urgency, feel situated inside a much older movement, whose earlier intensities are still arriving overhead in weakened but readable form. And perhaps that is the real payoff of following this subject all the way down. The deep universe does not just expand the scale of what we know. It changes the posture from which we know anything at all. It trains us out of first appearances. It teaches us that the world is older in every direction than instinct admits, more mediated than vision confesses, and more alive with hidden structure than brightness alone can reveal. If that is true, then the final step is not one more fact. It is a realization. The strangest thing happening in the deepest regions of the universe may not be confined to those regions. It may be the slow dismantling of our faith that reality should ever have looked simple in the first place. And maybe that is why the deepest observations do not leave us with chaos. They leave us with a more demanding version of coherence. A simple world is easy to cohere. A few objects, a few forces, a clean beginning, a readable middle, a future that unfolds in the same emotional register as the past. The actual universe is not giving us that. It is giving us a coherence built from layers that do not naturally fit human intuition. Ancient light from a once opaque cosmos still crosses the sky. Tiny irregularities in that ancient glow become later galaxies and clusters. Invisible mass lays down the gravitational terms under which visible matter can gather. First generations of stars alter the chemistry of what follows. Early radiation changes the transparency of the medium itself. Some young galaxies seem to have become bright and chemically active faster than many softer narratives prepared us for. Black holes begin exerting influence before the story feels ready for them. Expansion does not merely separate things, it changes what can remain knowable. None of that is simple. All of it hangs together. That kind of coherence is harder to love at first, because it does not flatter instinct. It asks more from us. It asks us to accept that explanation does not always make reality feel smaller. Sometimes explanation is what finally lets reality recover its true size. The deep universe is one of the clearest places where that happens. The old feeling was that the farther reaches of the cosmos must be blank, primitive, and emotionally remote. The newer feeling, if we let the evidence actually reach us, is almost the opposite. The deep cosmos is active, inherited, structured, and strangely intimate because it reaches us only through long, successful acts of transmission. There is no need to dramatize that. It is already enough. Enough that the phrase first light becomes heavier once we understand it. Enough that the word young becomes less innocent. Enough that darkness itself becomes layered. Enough that the night sky begins to feel less like an arrangement of visible things and more like an arrangement of visible consequences. That may be one of the strongest single corrections cosmology offers. We are not looking at isolated objects suspended in a neutral void. We are looking at consequences suspended in histories. A distant galaxy is a consequence of early fluctuations, invisible scaffolding, cooling gas, star formation, feedback, merger history, radiative environment, and the fact that its light happened to survive long enough to arrive here now. A black region of sky is not necessarily a place where nothing matters. It may be a place where our senses are simply outmatched, where the relevant structures are too faint, too old, too translated, or too hidden to announce themselves on easy terms. The universe is full of causation that does not glow. That sentence belongs far beyond astronomy, but astronomy lets us feel it with unusual force. We spend so much of life interpreting the bright part as the important part. The visible event becomes the whole story. The loudest factor gets mistaken for the deepest one. The deep cosmos keeps humiliating that habit. Again and again, the visible turns out to be downstream of something older, larger, or darker. Bright galaxies rest in halos we cannot directly see. Heavy elements reveal dead stars no one witnessed. The clearest image of the sky rests on a background of translated signals, missing information, and inaccessible remainder. Even the apparent present of the heavens is assembled from staggered emissions across different epochs. Once that becomes emotionally real, the universe begins to feel not less knowable, but more serious. Serious in the best sense. Not grim, not heavy for the sake of heaviness. Serious because it resists being reduced to scenery. Serious because every clear answer seems to open a deeper question about what made the answer possible. Serious because what we know now has been purchased by long patience, careful inference, and a willingness to let reality keep its scale. The deep universe is not a party trick for the intellect. It is a confrontation with layered truth. And layered truth has a particular aftertaste. It does not leave us inflated. It leaves us reoriented. We begin with the idea that we are looking out into distance. We end by realizing we are also looking into time, into hidden architecture, into translated signals, into limits of access, into the partial survival of information across an expanding space-time. We begin by assuming emptiness and primitive beginnings. We end with a universe whose earliest visible chapters already contain rapid assembly, environmental transformation, chemical memory, and signs of structural ambition. We begin by asking what strange thing is happening out there. We end by discovering that the strangeness also belongs to the conditions under which anything can be seen from here at all. That is a different kind of payoff than simple amazement. It lingers longer because it gets under the habits of perception. After a while, even ordinary words start carrying more weight. Empty, young, distant, dark, now. None of them stay clean. Each has acquired an underside. Empty may still contain fields, gas, curvature, and future consequence. Young may already be old enough for stars to have lived and died. Distant may really mean early. Dark may be loaded with structure. Now may be woven from arrivals that began long before us. And once those words change, the world below the sky changes with them. A street at night is still a street at night. A quiet walk home is still a quiet walk home. But overhead, the darkness no longer behaves like a blank container. It becomes a layered archive in motion. Nearby stars, distant galaxies, background radiation, and the unseen matter shaping it all occupy one field of attention without sharing one moment of origin. The familiar remains familiar, but it no longer gets to remain shallow. That may be the most generous thing knowledge can do. Not strip the world of feeling, but prevent feeling from settling for too little. Good cosmology does that. It does not ask us to abandon ordinary life for abstract grandeur. It asks us to let ordinary life sit inside a truer frame. The body remains local. The errands remain local. The griefs and pleasures remain local. But the local is no longer lonely in the old way. It exists downstream of an ancient and still partially readable history that surrounds us continuously. We live under delayed evidence. That is such a quiet sentence, and it changes almost everything. It means our sky is not merely beautiful, it is evidentiary. It means darkness is not just atmosphere. It is a medium through which messages have crossed. It means the deepest observable regions are not simply curiosities at the edge of interest. They are among the strongest proofs we have that reality is older, more indirect, and more structurally hidden than untutored perception can hold. And yet, for all that hiddenness, the universe is not mute. That may be the fact worth protecting most carefully from both sensationalism and boredom. It is not mute. The first great fog lifted enough to release light. The fluctuations remained. Matter gathered, stars ignited, galaxies formed, chemistry deepened, radiation changed the medium, black holes grew, ancient photons kept traveling. Expansion stretched their wavelengths but did not erase them. A species eventually emerged that could build instruments and ask what the faint arrivals meant. The chain was partial, contingent, and local, but it held. So by the time we reach the deepest regions of the universe, what we are really confronting is not only mystery, it is transmission. Transmission across distance, across time, across changing cosmic conditions, across the mismatch between what exists and what a human mind can comfortably picture. The strangeness is real, but the ability to detect the strangeness is just as real, and in its own way, just as astonishing. Which is why the right final feeling here is not triumph and not discouragement. It is a steadier thing, a kind of recalibrated presence. The knowledge that reality is far less simple than it first appears, that much of what matters is hidden, that the visible is often late and partial, that the deepest sky is busy with old consequences still arriving, and that consciousness, brief, local, breakable consciousness, still gets to stand beneath that sky and understand some of what it means. That is not a small ending. It only feels quiet because the universe has already done the louder part. So when we say that something strange is happening in the deepest regions of the universe, the line lands differently now. It does not mean that a few exotic objects have appeared in some remote corner and left the rest of reality untouched. It means the farther we push our view into the oldest visible layers of the cosmos, the less the old emotional bargain holds. We no longer get to think of the early universe as a clean emptiness waiting politely to become interesting. We no longer get to think of darkness as absence, of distance as mere separation, of light as a simple window, of visibility as a permanent right. The deepest sky has become a place where all of those assumptions fail at once. What we find there is not disorder, but a denser order than instinct can comfortably host. We find ancient light that began in a universe still close to its own beginning. We find the faint remains of tiny fluctuations that later became every larger structure we know. We find galaxies appearing early enough, bright enough, and in some cases chemically worked enough to force a revision in how quickly we thought the first great rounds of assembly could happen. We find signs that even youth, on cosmic terms, can already contain inheritance. We find that the visible parts of reality rest inside hidden scaffolds. We find that the medium itself was changed by the first luminous generations. We find that some of the largest truths available to us come only by inference from traces that have crossed an expanding universe for billions of years. And beyond all of that, we find horizon. Not the horizon of a hill or an ocean, where a faster ship might solve the problem. Horizon in the deeper sense, a boundary created by the age of the cosmos, the speed of light, and the expansion of space. A boundary that tells us our view is real, but not total, powerful, but not complete, intimate, but not sovereign. There is more than we can see. There may always be more than we can see, and some of what can still be seen now will not remain equally visible forever. That is a difficult thing for the human mind to hold, without either shrinking from it or turning it into abstract theater. But maybe it becomes easier if we return one last time to the simplest experience in the whole story, standing outside at night. The air is cool. Maybe there is traffic in the distance, maybe none. A few stars punch through city light, or many more if the sky is dark enough. To the unaided body, almost nothing seems to move. The heavens look still. The black between the points looks empty. The whole scene gives off a kind of finished calm. And yet we now know that calm is only surface. Above that ordinary moment is ancient radiation from a universe that once could not be seen through at all. Above that moment are galaxies so distant that to notice them is to intercept messages from near the beginning. Above that moment are regions where stars had already formed, burned, and died early enough to salt young systems with new elements. Above that moment are structures shaped by dark matter we have still never directly identified. Above that moment is a sky assembled from emissions that left at wildly different times and only happen to meet us together now. Above that moment is a finite archive. Beyond it, more reality. And woven through all of it is the quiet fact that what looks empty is often only what our senses are not built to read. The night does not become less beautiful once we know this. It becomes less innocent. That may be the best word for the change. Not bigger, though it is bigger. Not stranger, though it is stranger. Less innocent. The sky stops being a decorative ceiling and becomes a layered record. Darkness stops being a blank and becomes a field of hidden structure, delayed evidence, and inaccessible remainder. The present stops being a sealed container and becomes a meeting point for arrivals from different ages of the universe. That is what the deep cosmos really gives us if we stay with it long enough. Not just facts, a loss of innocence about reality itself. And that loss is strangely gentle. It does not humiliate us unless we insist on bringing childish expectations to a very old world. It does not tell us that human life is meaningless. It tells us that human life takes place inside an order far older and more intricate than immediate perception can confess. It tells us that ordinary experience is real, but not self-explanatory. It tells us that visible things are often late manifestations of hidden processes. It tells us that beginnings may already contain more history than the word beginning seems able to carry. It tells us that knowledge is local, partial, and still astonishingly deep. Most of all, it tells us that consciousness is a witness before it is a master. We are not outside the universe inspecting it from safety. We are within it, downstream of ancient events, catching whatever light has survived the crossing. We are temporary. Our instruments are temporary. Our theories will continue to sharpen, bend, split, and recombine as new evidence arrives. Nothing about our position permits arrogance, but neither does anything about it justify indifference. If anything, the opposite. The more contingent our access appears, the more extraordinary it becomes that access exists at all. The first stars did not form for us. The first galaxies did not gather for us. Reionization did not sweep the cosmos, so one day we could narrate it. Dark matter did not lay invisible foundations in order to satisfy our preference for elegant explanation. The universe was never trying to become legible to human beings. And still, by a chain of conditions so old and so unlikely to feel from inside a human life, some of it became legible anyway. That is where the final emotion lives. Not in triumph, not in fear, not in some polished slogan about being small. Smallness is true, and not nearly enough. The deeper feeling is more specific than that. We are late creatures in a universe that kept enough of its own early light intact for us to reconstruct part of the opening. We are local minds in a reality whose visible layer depends on hidden architecture. We are brief observers living during an era when ancient signals can still be gathered before parts of the larger archive drift farther into silence. We are not entitled to that position. We simply inhabit it. And maybe that is why the subject lingers after the facts are done. Because beneath all the redshifts and halos and deep fields and early galaxies is one quiet recognition that keeps returning. Reality is not only larger than we thought. It is more indirect, more inherited, more layered, and more alive with unseen structure than first sight ever suggests. The deepest regions of the universe do not merely extend the map. They expose the cost of pretending the map was ever the territory. So the next time the sky looks empty, finished, or still, it will be a little harder to believe your own eyes completely. And that is not a loss. It is a gift of correction. Above us is not a blank dark sprinkled with lights. Above us is a delayed and moving archive, full of early intensity, hidden support, translated messages, and horizons that remind us both how much can be known and how much will always remain beyond the reach of any local witness. That the universe should be like this is strange enough. That it should produce beings who can notice is stranger still.